Hey guys, welcome to another online math class. This video will be about arithmetic sequences, and by the end of this lesson we should be able to find the common difference in a sequence, be able to identify an arithmetic sequence, and finally be able to graph a sequence. Let's just pause the video here and take a couple of minutes to write these down. So we started off this topic by learning about sequences, and we found that the rule is sometimes each new term is made by adding a fixed amount to the current term or subtracting a fixed amount. So just going through some examples, in this case we're adding 5 to each number, in here we're adding 100 to each number, and this next one we're subtracting 5 from each number. So sequences that are generated by adding or subtracting a fixed amount to the previous term are called arithmetic sequences. So just make sure you've got that definition down, the one on the bottom. And if you do have it down, we'll move on to the next slide, and it's about common differences. So the fixed amount we add or subtract is called the common difference. So in this case will be 5, that first one, that second one will be 100, and that third one will be 5 again. And to represent the common difference, we often use the symbol D. So looking at an example here, it says find the common difference for the following arithmetic sequences and use it to find the fourth term in the sequence. So for question A, if we have a look, we're adding 3 each time. 2 to 5 we add 3, 5 to 8 we also add 3. So for question A, our common difference, or otherwise known as D, is going to be 3. And therefore our fourth term, that one here, will just be plus 3 to 8, and that gives you 11. And since it's the fourth term, I'll call it T4. Let's try question B now. We're also trying to find D, or the common difference. In this case, we're subtracting 2 each time. So you've got to show that we're subtracting 2. So in this case, it will be negative 2. That's our common difference. And therefore, our fourth term again is going to be 19. 21 minus 2 gives me 19. Now moving on, we're going to learn how to identify arithmetic sequences. So if a sequence is arithmetic, the difference between each term will be constant. So moving on to some examples here, we need to find out which of these are arithmetic. So looking at this first one, we're going to find the difference between each term here. So 21 to 28, we add 7. 28 to 35, we add 7. And 35 to 42, we also add 7. So we're adding a constant term. So because the differences between each term are the same, we call it an arithmetic sequence. So that's just the model answer you could have on the bottom left. And question B, let's have a look. So from 2 to 6, we add 4. However, 6 to 18, adding 4 doesn't work here. We would have to add 12 to 6 to get 18. And in this case, we'll have to add an even bigger number. So there might be a pattern going on here, but it's not an arithmetic sequence because we're not adding or subtracting the same number over and over. So down on the bottom right could be an example answer there. Now moving on, we're going to use the CAS a little bit. So this might not be anything new to you, but we're just going to quickly go through this just to make sure everyone has this down. So start off by pressing the main button and just pick any starting number you like. Let's go with 2 and let's add 4 each time. So just press plus 4, and once you get the answer, just press plus 4 again. And each time you get an answer, all the numbers on your right will be your arithmetic sequence there, because we're adding the same number over and over. So you don't need to write in your answer every time like that. Just press plus 4 and it will include your answer straight away. So nothing too difficult there. Just let me know if you do have any questions with that though. Otherwise, we will move on to graphs of arithmetic sequences. So there are some correlations between this and linear graphs. So if you have a look at these, and going back to the idea of slopes and gradients, a positive slope is a graph that goes up from left to right, and a negative slope is one that goes down from left to right. Alright, let's jump straight into an example question. So having a look at this one, it says the sequence 975 is arithmetic with the common difference D equals negative 2. So the best way to do this is to start off by drawing a table. Question A also tells us to do that. It says construct a table showing the term number and its value for the first 4 terms in the sequence. So term number is like T1, T2, I'll just call that 1, 2, 3, and 4. And term value is the value of that term, so that's like 9, 7, and 5, so I'll just add that in there. So in this case it says D equals negative 2, so we're subtracting 2 each time. 5 minus 2 gives me 3, so that will go in there. Alright, so that's our table. Once you've got our table, we need to make that into a graph. And to do that, we're going to need a Cartesian plane like so. So you can just sketch one out into your books, it doesn't have to look as nice as this. And once we've got that, we're going to plot those points in. Our first one is 1, 9, so that's about up here. Next one is 2, 7, that's down there. Next is 3, 5, that's over here. And next one's 4, 3, that is right there. And question C says describe the graph. I'll just show you guys a model answer so you guys have something to base your answers off. So we're looking for the slope, and you also got to tell me what the difference is, the common difference. So you could say something like the points of an arithmetic sequence with d equals -2 lie along a falling straight line. The line has a negative slope. And if it had a positive slope, you would just write a different value of d. So if it was going up by 2, you'd say d equals 2. And you'd say a rising straight line, and it has a positive slope. Otherwise, that brings us to the end of this lesson. Thank you guys for watching, and I'll see you guys all back online.